Yes, welcome. Calculator of conversion is very, very important in designing a reactor. Calculation of conversion. So we're going to be taking out a given calculation for conversion. And the question is the number 2 in the assignment, in the exercise that we're given. Question says a feed consisting of 30% of 50 micro, 50 mu meter radius or micrometer radius of particle, 40% of 100 micrometer radius of particles, and 30% of 200 micrometer radius of particle to be fed continuously in a thin layer onto a moving grate cross current to flow of reactant gas for the planned operating conditions. The time required for complete conversion is 5, 10, and 20 meters for the 3 sizes of particle. Find the conversion of solids on the grate for a resident time of 6 minutes in the reactor. So you are told to find the conversion for a resident time of 6 minutes. So solution, we consider this to be a plug flow with resident time Tp to be 6 minutes and a uniform gas compositions. Therefore, we use the formula 1 minus xp, which is actually the conversion we are looking for, to be equal to summation of 1 minus xbr of each of them times fr over f of each of them. So substituting values into the equation, because we have 3 particles, so we have 1 minus xp, I'm taking this one now, 1 minus xp to be equal to 1 minus xp for the first particle, which is actually 50 microns, and f of 50 over f, plus 1 minus xp for that of 100 times f of 100 over f, plus 1 over xp for that of 200 times f of 200 over f. So that is the formula that you're going to be using. But before that, we know that f of 50 over f is equal to 0.3 because we are given 30%. You can see 30% of 50. So that's why the f of 50 of f is equal to 0.3. And the time is 5 meters because we are already given the different times for their complete conversion, 5, 10, 20. So we'll get back f of 100 over f is 0.4, and the time of its complete conversion is 10 minutes. And that of 200 is 0.3, and the time of its conversion is 20 minutes. Now, because we don't have straight values for this value, 1 minus xp ri, we are going to use another relation, and this relation is made possible because for the 3 sizes, you can see the statement, because for the 3 sizes of particle, r1 is to r2 is to r3 is equal to tau 1 is to tau 2 is to tau 3, which are the times of conversions. So that means their radii is related to the time for complete conversion of each of them in that ratio format. So because of this, T over tau is equal to 1 minus RC over R, which is equal to 1 minus bracket 1 minus XP to power 1 over 3. So, but you can still just go to this last formula by saying 1 minus XP RI is equal to 1 minus TP, which is the resident time, all over tau R, which is the various times of conversion of each of them, all to power 3. So in essence, in this formula, instead of us using 1 minus xp ri, this 1 minus xp ri, we are going to be using 1 minus tp over tau r to power 3. So just take this and substitute for this in this equation, and individually for this. So that's what we are having here. We can see now we are now having 1 minus xp, which is the same as this 1 minus xp here. This 1 minus xp here, the same as this 1 minus xp. Because the one that has the total time of 5 minutes is converted before the residence time of 6 minutes. So we'll put the value to be 0. Now plus, in place of this 1 minus xp 50 micron, we'll put 1 minus TP all over tau for this very size, which is this formula that we gave here, 1 minus TP over tau for this very size to power 3. So that is 1 minus TP is 6, resident time all over time of conversion of this size is 10, all to power 3 times the what? F of 550 microns all over F, which is actually what we got here to be equal to, for this second one, to be equal to 0.4. So that's why we have 0.4 here. So we did for the second one, 1 minus 6 all over, this one is, we already got the time to be 20. So that's why we have 20 here. And we have the f of 200 over f to be 0.3, and that's why we have 0.3 here. So if we solve down, we have 0.128. Now 1 over xb is equal to 0.128. So xb alone is equal to 1 minus 0.1285 to give us 0.8715. So xb is actually equal to 87.15%. So let's look at the solution again. First of all, we say that we'll consider a plug flow of resident time. That's the first thing we do. Consider a plug flow of resident time 6 minutes and uniform gas composition, so that we use the formula 1 minus xp equal to summation of 1 minus xr f of ri over f. So we substitute, because we already know the different sizes that we are given to have the second line of the equation. Then where the f of the different size over f is already given to be 0.3, 0.4, and 0.3, and also their taus to be 5 meter, 10 meter, and 20 meter. And then because we are considering the three sizes to be in the relation of R1 is to R2 is to R3 to be equal to tau 1 is to tau 2 is to tau 3, we now say that T over tau is equal to 1 minus RC over R, which is equal to 1 minus xb to power 1 over 3, making the expression 1 minus xb Ri to be equal to 1 minus Tp over tau R all to power 3, which we are going to use in replacing those in the initial first equation, in this very first second line of equation that we have. So when we replace that, we have 1 minus xb to be equal to 0, 0 because the first particle is already converted at 5 minutes before the resident time of 6 minutes. Now plus 1 minus Tp over Tr, which is 6 over 10, all to power 3 times the f of the size over f, which is 0.4, plus for the second one, 1 minus 6 over 20, which is Tp over T of R of that one, all to power 3 times f of Ri over f for that one, which is 0.3. Added them up, it will give us 0.128, so that xb will be equal to 1 minus 0.1285, which will give us 0.8715. So in percentage form, xb is equal to 87.15%. So that is how we solve it. You can copy this down, this procedure line by line. It's very short, in one page, half a page you can do this. Please click on the subscribe button, like us in any way that you can, or pause in any way that you can. Thank you. God bless you. Success in your exams. God bless you.